On August 13th, NOAA's Climate Prediction Center quietly published an update that represents one of the sharpest single-month upgrades to a seasonal forecast in recent memory. The probability that this year's El Niño reaches very strong intensity by the end of the year jumped from 81% in July's outlook to somewhere between 90 and 95% in August's. And for the first time, forecasters are now giving real substantial odds, 69%, that this specific event will exceed every single El Niño measured since formal record-keeping began back in 1950. That would mean surpassing the legendary winters of 1982 and 1983, long considered the benchmark for how extreme this particular our climate pattern can get, an event still referenced by name in climate science literature more than 4 decades later. Behind that upgrade sits an even stranger, more specific piece of evidence that most casual coverage of this story has missed entirely. Scientists have detected an extraordinary pocket of stored heat sitting beneath the surface of the tropical Pacific. A subsurface temperature anomaly measured at 10 full degrees Celsius above normal, building months before this event would typically even approach its seasonal peak. This is the story of exactly what changed in NOAA's own data this month, why that hidden subsurface heat is the specific detail driving this dramatic upgrade, and what a potentially record-breaking El Niño actually means and does not mean for the months ahead. No exaggeration, just what NOAA's Climate Prediction Center and the International Research Institute for Climate and Society are actually reporting. Drop a comment and tell me if you have noticed any unusual weather where you live already this year that you suspect might be tied to this pattern, because a shift this significant genuinely does reach nearly every corner of the globe eventually, often in ways people never think to connect back to a single ocean temperature reading. I read every one of these. If you want grounded science coverage instead of recycled panic, subscribe. It is free, and a like helps this reach people before winter. Forecasts built on this exact data start shaping travel plans and farming decisions everywhere. Let us go for 5,000 likes on this one. Now let us get into it. To understand why this specific upgrade matters so much, you first need a clear picture of what El Niño actually is, and how scientists measure its strength in the first place. El Niño describes a periodic warming of sea surface temperatures across the central and eastern tropical Pacific Ocean, triggered when the trade winds that normally blow steadily from east to west across that stretch of ocean weaken significantly, sometimes even reversing direction for a time. Under ordinary conditions, those trade winds pile warm surface water up against Asia and Australia while allowing cooler, nutrient-rich water to rise up along the coast of South America, a process oceanographers call upwelling, and one that sustains major fisheries along that coastline for the same reason it keeps ocean temperatures there comparatively cool under normal conditions. When the winds weaken, that warm water sloshes back eastward instead, spreading out and eventually settling directly over the cooler water near South America like a lid, a shift that reorganizes where thunderstorms and rising air concentrate above the tropical Pacific, and, from there, reshapes high altitude wind patterns, steering weather across enormous stretches of the planet, sometimes thousands of miles from the Pacific Ocean itself. Scientists track the strength of this shift using something called the Niño 3.4 index, measuring how far above average sea surface temperatures are running across a specific, closely monitored stretch of the central Pacific, with NOAA's official Relative Oceanic Niño Index, or RONI, now serving as the standard method for classifying any given event's strength against the full historical record, replacing older measurement approaches that made comparing events across different decades considerably less reliable. Here is the specific number that has forecasters genuinely paying attention this month. The latest weekly Niño 3.4 reading, centered on August 12th, came in at plus 2.7 degrees Celsius above average, a genuinely striking figure this early in the seasonal cycle, since El Niño events typically do not reach their peak intensity until winter. For context on how quickly this event has been accelerating, the broader 3-month seasonal average across May, June, and July sat at a more moderate plus 1.51 degrees Celsius, but the July monthly value alone had already climbed to plus 2.03 degrees, meaning the pace of warming picked up dramatically in the span of just a few weeks. NOAA's own forecast now places the median expected value for the October through December period at plus 2.66 degrees Celsius, and it is worth pausing on that specific number because the strongest El Niño previously on record, the winter of 1982 and 1983, peaked at plus 2.4 degrees Celsius using the same official index. If NOAA's current median forecast holds, this event would not simply rank among the strongest ever measured. It would actually exceed the previous record outright. The reason forecasters felt confident enough to raise their probability estimates this specific month traces directly back to that subsurface heat discovery. sea surface temperature alone only tells part of the story, since a genuinely powerful El Niño needs a deep, sustained reservoir of warm water beneath the surface to keep feeding the event as it develops, rather than a shallow, warm layer that could cool off quickly once conditions shift even slightly. NOAA's August assessment specifically flagged localized subsurface temperature anomalies reaching an extraordinary 10 degrees Celsius above normal, a genuinely unusual reading for this point in the year, well before the subsurface warm pool driving an El Niño event would typically reach its own seasonal maximum. That detail matters enormously for the forecast's credibility, because subsurface ocean heat functions almost like a stored fuel supply, warm water sitting below the surface that continues percolating upward and reinforcing the surface warming for months afterward, meaning an unusually large subsurface reservoir this early is a genuinely strong signal that the event still has considerable room to intensify further rather than leveling off anytime soon. Separately, the Niño 1+2 region, a smaller monitoring zone closer to the South American coastline that tends to react first and most sharply to changes in this pattern, registered a reading of plus 2.9 degrees Celsius, another data point reinforcing the picture of an event still actively gaining strength, rather than one that has already reached a plateau. There's a second piece of evidence behind this upgrade worth understanding clearly, because sea temperature alone, however dramatic, is not actually sufficient on its own to officially classify a strong El Niño event. Scientists specifically look for the atmosphere to become coupled to the warming ocean, meaning the actual wind patterns, cloud formation, and rainfall across the tropical Pacific have to visibly respond to and reinforce that ocean warming, rather than the ocean simply running warm in isolation while the atmosphere above it continues behaving normally. This coupling requirement exists specifically because ocean temperature anomalies can and occasionally do occur without producing the full range of weather impacts associated with a genuine El Niño event, meaning a warm ocean alone is a necessary but not sufficient condition for forecasters to have real confidence in how the season ahead will actually unfold. NOAA's August assessment was explicit that this coupling has now firmly taken hold, with trade winds continuing to weaken and atmospheric circulation patterns clearly realigning in a way consistent with a genuine, self-reinforcing El Niño event, rather than a temporary ocean temperature spike that might fade without producing the kind of widespread weather impacts this pattern is known for. That combination, extraordinary subsurface heat plus confirmed atmospheric coupling, is precisely why forecasters felt justified making as large a probability jump as they did within a single monthly update, rather than the more incremental, cautious revisions typical of most seasonal outlooks. It is worth walking through the specific probability numbers in more detail, because the shift between July and August genuinely was unusually large by the standards of how these outlooks normally move. In July, NOAA placed an 81% chance on a very strong El Niño developing during the October through December window. By August, that figure had climbed to somewhere between 90 and 95%, depending on which specific NOAA product you consult, with the August 13th CPC diagnostic discussion placing it above 90% directly. Looking specifically at the odds of this event surpassing every previously recorded El Niño, NOAA's own analysis now puts that probability at 69% for the October through December period. Specifically, a genuinely remarkable figure given how rare such record-breaking events have historically been. The forecast does ease somewhat moving into early winter, with the probability of very strong conditions sitting around 90% for the November through January window and closer to 70% for December through February, reflecting the genuine uncertainty that naturally increases the further out any seasonal forecast extends, even as the underlying trajectory remains firmly pointed toward historic territory. That gradual easing across successive 3-month windows is a normal, expected feature of how these probabilistic forecasts behave, not a sign that confidence in the underlying event itself is fading, since forecasters simply have less certainty the further into the future any specific 3-month window sits relative to the date the forecast was actually issued. There is a useful, longer historical context worth understanding here as well, because events of this magnitude are genuinely rare rather than a routine feature of any given year. Since formal record-keeping began in 1950, only 5 El Niño events have reached the informal threshold some meteorologists use to describe a super El Niño, sea surface temperatures at least 2 degrees Celsius above average, occurring in the winters of 1972 and 1973, 1982 and 1983, 1991 and 1992, 1997 and 1998, and most recently 2015 and 2016. 2 additional events are believed, based on less complete historical records, to have reached comparable intensity even earlier, in 1888 and 1889, and again in 1877 and 1878. That rarity, roughly 1 genuinely extreme event per decade across the modern record, is exactly why NOAA's current forecast is drawing this much attention from climate scientists specifically, since a confirmed record-breaking event would represent something meaningfully outside the range of what any living person has directly experienced before, with the possible exception of those who remember the 1982 to 1983 winter specifically. Each of those 5 previous super El Niño events left a distinct mark on global weather history. The 1997 to 1998 event alone is estimated to have caused tens of billions of dollars in damage worldwide through a combination of flooding, drought, and disrupted fisheries, while the 2015 to 2016 event contributed to a period of record global average temperatures at the time, illustrating that an event of this magnitude tends to leave measurable consequences well beyond any single season's weather headlines. It is worth being precise about what this forecast does and does not actually guarantee, because NOAA's own scientists have been careful to add real caveats alongside these dramatic probability numbers. The agency has explicitly cautioned that even a very strong or potentially record-breaking El Niño will not produce its characteristic effects uniformly everywhere, since a stronger event increases the likelihood of typically associated regional weather patterns without determining the exact timing, location, or severity of any individual storm, cold snap, or period of heavy rainfall. NOAA's own forecast range reflects that genuine uncertainty directly, with the middle 50% of model outcomes for the October through December period spanning from plus 2.37 to plus 2.95 degrees Celsius. A real spread rather than a single fixed number, meaning the event could still land anywhere within a meaningfully wide range, even as the median forecast points toward historic territory. That spread matters because even a somewhat lower outcome within that range, say plus 2.4 degrees, would still statistically tie the previous 1982 to 1983 record rather than clearly exceed it, meaning the 69% probability of a genuinely unprecedented event still leaves real room for this El Niño to land as merely historic rather than definitively record-breaking. It is also worth noting that NOAA and the Climate Prediction Center have historically tended toward conservative forecasting on events like this one, and that a number of independent forecasting models are currently projecting even warmer outcomes than NOAA's own official median, suggesting the probability of a record-breaking event could plausibly climb even further in forecasts released over the coming weeks, though nothing is locked in until the actual data arrives. The practical consequences of an El Niño. This strong extend across a genuinely wide range of global weather patterns, and it is worth understanding the general shape of those impacts even though NOAA's own caveats about specific timing and location still apply. Historically, strong El Niño winters tend to bring wetter, cooler conditions across the southern tier of the United States, from California through Texas and into Florida, while the Pacific Northwest and Northern Rockies typically see warmer, drier conditions with thinner mountain snowpack, a pattern that can meaningfully affect water supply planning across the West well into the following summer. Atlantic hurricane activity tends to run below average during strong El Niño years, since the same atmospheric pattern that reorganizes rainfall also tends to increase wind shear across the Atlantic and Caribbean, making it considerably harder for storms there to organize and intensify, even as the eastern and central Pacific basins typically see increased hurricane activity under the exact same broader pattern, precisely the kind of opposite basin effect this particular hurricane season has already demonstrated. Globally, past strong El Niño events have been associated with drought conditions across parts of Australia, Indonesia, and southern Africa, alongside increased flooding risk across East Africa and parts of South America. Impacts this particular event would plausibly amplify if NOAA's current forecast trajectory holds through the winter months ahead. Agricultural markets also tend to feel these effects with a lag, since disrupted growing seasons for crops like rice, palm oil, coffee, and wheat across El Niño-sensitive regions frequently show up as modest price increases at the grocery store months after the actual weather anomaly first develops, a ripple effect most consumers never directly connect back to a Pacific Ocean temperature reading published earlier in the year. There's also a genuinely important timeline detail worth understanding, since this event is not expected to simply peak and fade quickly once winter arrives. NOAA's current assessment places the odds of El Niño persisting all the way through the Northern Hemisphere spring of 2027 at roughly 97%, meaning the broader climate pattern driving this year's weather anomalies is very likely to remain in place for a considerably longer stretch than a single winter season alone. That persistence matters for anyone trying to plan around this forecast at a practical level, whether that involves agricultural planning tied to expected rainfall patterns, water resource management in drought-prone regions expecting relief, or simply understanding that unusual weather patterns tied to this event are likely to keep showing up well into next year, rather than resolving cleanly once the calendar turns to January. A pattern This durable also means seasonal outlooks published for next spring will very likely still be shaped by this same underlying event, even after the sharpest winter impacts have already passed, since the gradual transition back toward neutral ocean conditions tends to unfold over a period of months rather than happening abruptly once the calendar peak of the event has technically passed. So what does all of this actually mean for you, regardless of where you happen to live? The practical lesson is not that any specific storm, drought, or unusual weather event happening right now can be definitively attributed to this El Niño forecast, since NOAA's own scientists are explicit that strength alone does not determine individual weather events with that kind of precision. What it does mean is that seasonal outlooks published over the coming months for winter precipitation, temperature trends, and regional drought or flood risk are very likely to lean more heavily than usual on this specific, potentially record-breaking El Niño as their underlying driver, making it genuinely worth understanding this pattern in some detail before those more specific regional forecasts start arriving later this fall. If you live somewhere with a well-documented historical relationship to El Niño, the wetter Southern California and Gulf Coast pattern, or the drier Pacific Northwest pattern, this is a reasonable moment to start paying closer attention to how those seasonal outlooks develop over the coming weeks, given how unusually high confidence NOAA is currently expressing in this event's eventual strength, since a forecast this confident, this early in the season, is itself a somewhat unusual signal worth taking seriously, regardless of where you happen to live. The honest, grounded summary is this. NOAA's August Climate Prediction Center update raised the probability of a very strong El Niño developing by the end of 2026 from 81% to above 90%. And for the first time gave real odds, 69%, that this specific event could exceed every El Niño measured since formal record-keeping began in 1950, surpassing the previous record set during the winter of 1982 and 1983. That upgrade was driven specifically by newly detected subsurface ocean heat reaching an extraordinary 10 degrees Celsius above normal, combined with confirmation that the atmosphere has become genuinely coupled to the warming ocean rather than lagging behind it. Two technical markers scientists rely on to distinguish a genuinely powerful, self-reinforcing El Niño from a more modest or short-lived warming event. NOAA's own forecast carries real, acknowledged uncertainty with a meaningful range of possible outcomes rather than a single fixed number. And the agency has been explicit that even a record-breaking event will not produce its characteristic effects uniformly everywhere across the globe. The event is expected to persist with roughly 97% confidence through the spring of 2027, meaning its broader influence on global weather patterns, from Pacific Northwest snowpack to Atlantic hurricane activity to East African rainfall, is likely to extend considerably beyond this coming winter alone. We are going to keep tracking this event the way we tracked it today, straight from NOAA's Climate Prediction Center and the International Research Institute for Climate and Society, not recycled headlines. Subscribe so you do not miss it as NOAA's monthly updates continue rolling in over the coming months, because based on how significantly this month's numbers already shifted, further updates are very likely to matter just as much, whichever direction they ultimately move, and leave that comment below. Tell me if you remember the 1982 to 1983 El Niño winter, or if this would be the first genuinely historic event of this kind you have lived through, because that generational gap is exactly why this specific forecast has captured so much attention among the scientists who study this pattern for a living. Because behind every one of these probability percentages is a climate scientist watching subsurface ocean temperature data climb into territory their models have never had to account for before. A farmer somewhere already adjusting planting decisions around a winter forecast that keeps shifting warmer with each passing month. A water manager in the American Southwest recalculating reservoir projections against the possibility of a genuinely wet winter after years of drought planning. And a coastal community in California quietly hoping this year's version of a wetter, stormier winter arrives gently rather than all at once. 5,000 likes on this one. Let us go. See you in the next one.